As dawn breaks at 0900 hours local time, a Ukrainian drone operator positioned near Kherson completes his pre-flight preparations. The battery reads green. The shaped charge sits secure. Beneath the fuselage of a British cargo drone, originally designed for hauling livestock across the Australian wilderness, hangs 50 kilograms of explosives suspended by cable. Between this operator and his objective stretches 4 kilometers of devastated terrain and a river crossing. The target looms ahead, a bridge. Neither he nor the system's monitor tracking from behind realizes that a Russian listening installation across the water has already detected their signal before the aircraft even leaves the ground. Half a second passes, and 6 Ukrainian first-person view drones launch from their positions. The first FPV screams across the Konka River at 120 kilometers per hour before diving into a sandbagged Russian emplacement near the bridge's far terminus. Its fragmentation charge detonates violently, sending sandbags scattering. What just struck that position represents cutting-edge reconnaissance technology, a pilot viewing everything through a camera feed as though controlling a video game. Except this particular game costs approximately $400 per unit, and the operator sits 4 kilometers away in a trench. 4 additional drones follow in pairs, slamming into fortified positions and gun placements dotting the opposite bank. Smoke billows across the Russian line. The T-150 lifts skyward and accelerates into the corridor. The aircraft now crossing enemy lines is a Malloy T-150, a British heavy lift platform originally engineered to transport supplies across Australia's remote interior. It carries a payload capacity of 68 kilograms, achieves maximum speeds around 130 kilometers per hour, comparable to highway traffic, travels a range of 70 kilometers, and runs on electric motors silent enough to whisper past sentries. Essentially a flying pickup truck, modified to carry ordnance. The Australian ranchers who conceived this design certainly never imagined this application. The landscape below resembles the moon. 2 years of continuous bombardment transformed this riverbank into something resembling World War I's Western Front. Overlapping shell craters stretch endlessly. The burned-out carcass of a city bus sits abandoned on a road unused for months. A collapsed apartment structure displays reinforcement bars protruding from debris like skeletal fingers. The T-150 pilot threads his aircraft through the wasteland, the 50-kilogram charge swinging with every adjustment. Flying a half-ton explosive on a pendulum proves every bit as stressful as imagined. At approximately 60 meters altitude, the drone appears as merely a dark speck against gray sky. The FPV bombardment running simultaneously ensures nobody across the river looks upward. The monitor screen displays 2 simultaneous feeds. Neither belongs to the Ukrainian crew. Both represent active Russian FPV camera views, broadcasting the incoming Ukrainian attack drones directly from the Russian pilot's own goggles. Nobody on the opposite bank notices the T-150 crossing no man's land. The suppression strategy works perfectly. The equipment on this screen represents the Chuika 3.0, an indigenous Ukrainian drone detector capable of intercepting the live video feeds that Russian FPV operators transmit to their controllers. Whatever Russian pilots observe through their goggles appears simultaneously on the Ukrainian crew's display. Imagine tapping into the home security system of someone breaking into your house. Currently, both video streams remain locked onto the barrage, showing clear reception. Nevertheless, the T-150 remains vulnerable. Quiet operation, minimal thermal signature, and extreme altitude render it nearly invisible as a speck. However, Every control input transmits radio frequency signals from the command station toward the aircraft. Across the river, a Russian electronic warfare specialist completely ignores the FPV bombardment. Instead, he concentrates on monitoring steady RF emissions originating from Ukrainian positions. These transmissions prove considerably more intense and sustained than standard FPV signals. He picks up his handset and relays the bearing information. The operators haven't yet grasped it, but the predator-prey dynamic has commenced, and they represent the prey. The system responsible for locating them goes by the name SkyPoint 2, and it performs no jamming or interference. It simply listens. Each time the pilot manipulates the control stick, the SkyPoint 2 detects the RF signal, identically to how someone overhears a telephone conversation in a quiet space. Meters. Think of it as caller identification for drone pilots. It doesn't disconnect the transmission, though it reveals which residence the signal originates from. Electronic equipment costing perhaps $15,000 just provided Russian forces the exact coordinates of a drone valued thrice as much and the two-person crew operating it. Yet the operators cannot detect they have been found. Since the SkyPoint 2 transmits 0 watts, the Chuika continues displaying a clear screen, while Russians zero in on the operational bunker. The T-150 leaves the final stretch of contested territory and crosses the Konka River. Through the camera lens, the bridge materializes, as though someone fired a shotgun into a parking lot. Craters perforate the surface everywhere. Ragged perforations pierce completely through the deck from months of HIMARS bombardment. HIMARS represents the American rocket artillery platform that has systematically obliterated Russian supply concentrations throughout Ukraine, starting in 2022. 90-kilogram warheads launch 70 kilometers downrange, impacting within meters of intended coordinates. Against this bridge deck, strikes repeatedly damaged the wrong structural layer. Through the most substantial crater, the pilot glimpses the river 30 feet beneath and realizes the bridge remains standing precisely because bridges withstand punishment delivered from above. That constitutes their fundamental purpose. Launching rockets onto the deck resembles pounding a table. You'll damage the surface and possibly perforate it, yet the supporting legs remain unfazed. The piers sustaining this span simply absorb such impacts without concern. Regarding the cargo this drone transports, the operators possess something HIMARS never had: an exact blueprint of the infrastructure concealed underneath this deck. How they obtained it constitutes a story warranting confiscation of every communication device throughout the Russian military, though we shall address that matter presently. The shaped charge dangling from the cable concentrates everything toward a single location, comparable to the difference between striking water with your hand versus puncturing it with a needle. Every crater across the deck now functions as a delivery channel. The drone flies across the opening. The charge descends along the cable, and suddenly this bridge receives impact from the single direction nobody engineered it to withstand. The operator centers his targeting on a crater positioned near. Looking through it, he observes the column itself, a substantial concrete structure extending from the riverbed to the deck underside. That represents the actual target, not the road surface itself, but rather the column. The pilot commences his approach from 1 kilometer away. Across the river, the pair of SkyPoint 2 stations have triangulated the signal precisely. An operational bunker sitting 4 kilometers from the bridge. The operator transmits the coordinates to his commanding officer, who rapidly calculates options. Artillery demands excessive time. FPVs respond quicker, though Ukrainians operate drone detectors, and they will remain sheltered. He requires them exposed. He directs 2 FPVs toward the bunker, not for destruction, but for flushing, and simultaneously requests a Lancet to execute the strike once the crew abandons shelter. The Chewika emits a piercing alarm. 2 Russian FPV camera feeds materialize on the detector, approaching rapidly from across the river and heading directly toward the bunker. The barrage failed eliminating every Russian crew, and the screen displaying pristine reception 30 seconds ago has transformed into the most critical display in the entire position. 90 seconds remain before the Russian FPVs arrive at the bunker. The operators perceive them approaching, and that represents precisely the intended effect. What remains inaudible to them is 200 meters overhead, a Lancet circling silently on electric motors, anticipating their emergence. Twin emergencies approach simultaneously from opposite directions. The Russian FPVs sit 50 seconds away, while the T-150 remains 1 kilometer from the bridge. The pilot observes the Chewika, positioned above the system's monitor shoulder. The pair of incoming feeds advancing with each display refresh. He cannot influence that situation. What he can accomplish involves positioning this charge on target before everything collapses. Suddenly, his monitor disintegrates. The video transmission fragments into pixelated static, freezes momentarily, reappears briefly, and then locks completely. He pushes the control stick rightward and receives no response. 1 full second later, the drone lurches eastward, the explosive charge swinging beneath, and the pilot navigates blind through 1-second transmission delays between each command and aircraft response. He shifts the frequency of the command station, standard counter-jamming protocols, the fundamental lesson taught initially. The feed refuses to clear. Should the signal drop entirely, the drone drifts uncontrolled, carrying 50 kilograms of live ordnance until battery depletion forces a crash landing anywhere. The system hitting the drone's control connection represents a SERP VS-5, a Russian jamming platform positioned across the river. The SERP disregards GPS entirely. The T-150's anti-jamming systems manage satellite positioning independently. The SERP targets the RF control connection, the radio bridge between the pilot's controls and the aircraft's motors. It inundates the frequency with noise across every band the drone utilizes and submerges the actual signal in static. That explains why frequency shifting proved ineffective. No clean frequency exists for switching to. A jamming apparatus costing roughly $40,000 threatens destruction of a mission worth approximately $500,000, considering the drone, shaped charge, FPV bombardment, fire support, and 2 operators requiring 6 months training. It maintains effective coverage to 5 kilometers, and the T-150 flies directly toward it. The vicious component involves this scenario. Imagine someone pressing an air horn against your receiver, while everybody else in the room conversates normally. That represents the SERP. The T-150's control inputs deteriorate into unpredictable movements, while Russia he maximizes the transmitter output to penetrate the jamming. The video feed snaps back into view, still stuttering intermittently, though sufficient for navigation. He corrects the drift and steers the T-150 back toward the bridge. Yet each additional watt rescuing the aircraft also compromises the crew. Amplified transmission strength means the SkyPoint 2 receives a more robust, cleaner signal. The system's monitor examines the Chuika and observes the pair of Russian FPV feeds tightening their orbit around the bunker. The reinforced signal just transmitted exact transmission coordinates to the SkyPoint 2. The pilot triumphed regarding aircraft control. The consequence involves the Russians possessing precise knowledge of his location. The pilot recognizes the Chuika feed. The Russian video streams circling more tightly with every rotation. He commits to the holding pattern regardless. The shaped charge requires manual deployment. The T-150 arrives above the bridge and he decelerates to a hover, searching for the target crater. Wind pushes the aircraft 2 meters eastward. He compensates and engages the descent command. The winch mechanism commences paying out cable, and the charge lowers into the opening. Steadily and deliberately, oscillating with each breeze, on camera, it descends below the deck 8 meters, 7 meters. Each adjustment arrives half a second after wind has already repositioned the aircraft. He pursues the physics rather than predicting it ahead. Subsequently, the camera floods with muzzle flashes. Heavy machine gun, opposite bank, fortified position, perhaps 400 meters distant. Tracer rounds streak across the display. The initial volley passes beneath. The next volley draws closer. The muzzle flash displayed represents a DSHK, a 12.7mm heavy machine gun, a weapon ruining operators' schedules since 1938, because ballistic physics shows no respect for age. A 12.7mm projectile at 400 meters penetrates light protective layers, and the T-150 consists of carbon fiber and plastic. The weapon discharges 600 rounds each minute. At this distance, bullets arrive preceding the sound. The gunner spots the drone, squeezes the trigger, and impacts already travel toward their destination, while the noise still traverses the river. Targeting the T-150 with a shaped charge attached resembles throwing basketballs at a piñata, except the piñata exceeds the gunner's truck in monetary value, and the interior contains 50 kilograms of shaped explosive. The pilot cannot evade without compromising cable positioning. Maintaining the hover and accepting fire represents one option. Abandoning the mission represents another. He requests suppression support. A Ukrainian FPV zeroes onto the flash source and races across the river. The gunner crouches behind the emplacement barricade half a second before the FPV demolishes the sandbags. The machine gun falls silent. But that FPV belonged to the protective barrage, and every new problem the T-150 encounters pulls another drone from suppression to address it. 8 FPVs commenced this mission. 5 have already been expended. The pilot operates a suppression barrage with practically nothing left. Additionally, the Russians absorb the pattern. The barrage has bombarded identical positions for 6 minutes, the trenches Ukrainians recognized beforehand. Positions the Ukrainians overlooked are awakening. The second machine gun commences fire from a concealed bunker 300 meters southward, a position the protective barrage never targeted because nobody possessed prior knowledge of its existence. The pilot views tracers drifting through the camera frame while keeping his hands locked onto the hover control. Deploying another FPV proves impossible. Back at the bunker, the initial Russian FPV arrives. The operators hear the wail of 4 propellers at maximum power before it registers on the Chuika display. Near, roughly 20 meters overhead. The Russian camera view shows their bunker's uppermost section from directly above. Sandbags, camouflage netting, the shadowy rectangle of the entrance. The FPV descends. The counter-drone team, positioned in an adjacent trench, swings a shotgun upward. The buckshot shreds plan of propellers, and the FPV cartwheels into the soil, 3 meters from the fortification. The explosion showers the netting with shrapnel, though the sandbags withstand the impact. The second Russian FPV arrives low and accelerated from the north. An approach the shotgun crew fails to protect and detonates against the outer wall. The concussive wave strikes the operators squarely and dislodges the Chuika from its bracket. The system's monitor captures it mid-tumble. The screen flickers and stabilizes. 3 additional feeds converge from multiple trajectories. He grips the pilot's shoulder. The pilot maintains focus on his screen. I understand. He examines his display. The T-150 hovers above the crater, with the column evident through the opening. Cable descends 6 meters. 4 remain. Approximately 40 seconds of winch deployment, time the pilot no longer possesses. Should those 3 approaching FPVs penetrate the entrance, the bunker becomes a tomb. Should the operators evacuate, they face exposure. He releases the control stick and engages the T-150's autopilot hover function. The charge dangles 4 meters from the column. Undeployed, not detonated. Both operators snatch their gear and bolt from the rear entrance into the communication trench. 40 meters separate them from the backup bunker, connected via trench though, with a vulnerable 10-meter section where the wall has collapsed. They sprint through the exposed area at maximum velocity, 10 meters traveling unshielded. The system's monitor perceives something unexpected, a high-pitched electronic whine descending vertically, intensifying progressively faster than anything traversing horizontally. He glances upward and identifies a dark form descending at an angle inconsistent with anything operating with their side. He forcefully shoves the pilot sideways into the bunker entrance. The detonation impacts the collapsed trench segment they traversed 2 seconds earlier. A warhead penetrates the compacted earth, and the shockwave travels through the trench system like a violent blow to the torso. Both operators occupy the bunker interior, ears ringing, dust coating their mouths, yet breathing. 10 meters behind their previous position, a crater marks the impact. A crater non-existent 3 seconds prior. The ordnance just striking represents a Lancet III, the genuine weapon throughout this engagement. Weighing 12 kilograms total, with a 2.5-meter cross-shaped wing configuration, approximately the dimensions of a coffee table with wings, it launches from a catapult rail, ascends on electric power, and loiters approximately 40 minutes maximum, circling patiently and silently across territory comparable to downtown Los Angeles in area, observing via a Zala reconnaissance drone positioned still higher. Once the Zala designates the target, the Lancet's operator directs it toward impact, utilizing a television camera mounted in the nose cone. A person with a controller maneuvering a 3-kilogram shaped charge into an objective, like descending a chimney. The warhead itself weighs 3 kilograms, seemingly insignificant, until recognizing it comprises a shaped charge engineered to perforate the overhead armor protecting a T-72 tank. It maintained position 200 meters above the bunker for 4 kilometers. The Chuika never detected it because the Lancet communicates with its operator employing completely distinct digital protocols from the analog transmissions the detector was programmed to intercept. The shaped warhead it carries underwent development to breach tank protection systems traveling 250 kilometers per hour, descending vertically. Once audible, the motor whine delivers approximately 3 seconds notice. The FPVs never constituted the primary weapon. They functioned as hunting dogs, flushing game from brush. The Lancet represented the rifle, waiting for the birds to take flight. The command station sustained operation. The Chuika continues functioning. 4 kilometers distant, the T-150 drifts eastward in autopilot mode. Charge suspended from cable. No pilot manually controlling inputs. The system's monitor activates his radio. Mortar battery, grid coordinate. Deliver maximum firepower. 12 seconds elapse. Then, the initial 120mm round impacts the opposite bank, with a crack reverberating across the river. Subsequently, the second round. Then the battery establishes rhythm, and the opposite bank vanishes beneath a curtain of brown earth and gray smoke. 4 rounds launched per gun, advancing northward to southward progression. Radio static replaces conversation. The second machine gun ceases mid-discharge. Russian FPV launches terminate abruptly. For 60 seconds, the only phenomena crossing the Konka comprise mortar rounds, plus 1 British livestock drone carrying a bomb suspended from string. The pilot fumbles the command station from its case, hands trembling uncontrollably. Lancet impact dust still descends onto the screen. He wipes it clean, reactivates the transmitter, and awaits response. 2 seconds of static. 3 seconds. The aircraft should still exist. Subsequently, the screen vibrates and video returns. Bridge deck, crater, cable still fastened, charge still residing inside the opening. Completely undamaged. He exhales. Suspending breathing for 4 minutes creates that reaction. He grasps the control mechanism, nudges the T-150 back above the opening, aligns the charge centrally. The cable releases the final 4 meters. Through the camera, the shaped charge seals against the support column, and the pilot comprehends precisely which column requires destruction, because a Russian serviceman transmitted them the blueprint. Not during a debriefing session, not via intelligence channels. The individual posed for an Instagram photograph underneath the bridge. Broad grin, rifle carried across body, celebratory stance. He inadvertently framed the complete support architecture of every column maintaining this span. Ukrainian engineers captured his photograph, assessed the column dimensions, and engineered the shaped charge to correspond precisely. Your spouse instructs you against sharing everything on social platforms. Her guidance proves correct. He activates the release mechanism. The T-150 ascends, 50 kilograms lighter. He maneuvers it westward, and the T-150 accelerates toward the Ukrainian bank at full speed. The system's monitor secures the detonator and observes the video transmission. 200 meters. Sufficient distance that the detonation cannot impact the aircraft. The T-150 traverses. He activates the detonator. The shaped charge drives a superheated plasma jet of metal and gas into the column at 8,000 meters per second. The concrete experiences no cracking. It disintegrates entirely. A shaped charge costing approximately $300 accomplished what 6 consecutive months of multiple millions in HIMARS expenditure could not accomplish. A deck segment sags and drops 15 centimeters, accompanied by a groan audible across the river. Not a catastrophic collapse, not immediately. Yet another structural component maintaining this bridge's equilibrium has vanished. If you appreciated this presentation, examine our additional footage featuring an even more extensive strike in Ukraine. Until